Once again, we welcome you, the Senior 5 students. I'm still teacher Agaba Kosma, a physics and mathematics teacher, handling A-level mathematics paper 1. And from the start, our topic has been trigonometry. We have moved some good journey. We have reached an extent of solving some trigonometrical equations. We shall keep solving more equations at every step. We learn a new thing about trigonometry. We use it to solve equations. But now, before we may go far, we need to look at the types of angles. That is our topic for today. So what are you required to be knowing by the end of this lesson? If you are able to explain the different types of angles and you can identify them and their different quadrants in which they lie. And then you also have the capacity to derive some trigonometrical ratios for special angles of 30 degrees, 45 degrees, and 60 degrees. Then we shall celebrate and we shall congratulate ourselves. So let's go straight forward to types of angles, and which I'm very sure they are not very new to you. You have seen these angles since primary and we are still following them. So the first, we shall have acute angles. So what are acute angles? I'm sure you know. I will not take time. These are the angles. These are angles between 0 degrees and 90 degrees. An angle of 60, an angle of 35, an angle of 7 degrees are all acute angles. And these angles are actually found they lie in the first quadrant. Even if I stop there, an angle of 90 is not part of that. It is not inclusive. Then what is an angle of 90? We call it a right-angled triangle. I'm not going to write that one. We know an angle of 90 is a right-angled triangle, and an angle of 180 degrees is a straight line angle. That's the same as 0 and 360 degrees. Let's have another category. Obtuse angles. These are angles between 90 degrees and 180 degrees. Those are obtuse angles. Just to remind us, you have known these things. For example, an angle of 120 degrees, an angle of 100, an angle of 91, an angle of 179. All those angles are obtuse angles. And when you see these angles, they are in this quadrant between 90 and 180. Therefore, they are found they lie in the second quadrant. Can have the last category that we shall look at, and those are reflex angles. What are they? These are the ones between 180 and 360. These are angles between 180 degrees and 360 degrees. So if you try to represent them, you'll find that those angles, they are the angles in this region, 180 and 360 degrees. And those angles, they lie in the two quadrants, the third quadrant and the fourth quadrant. Those are our types of angles. And then we are going to use them. We shall use them to solve some problems. Let's have Examples. Given that sine theta equals 3 out of 5, given that sine theta is 3 out of 5 and that theta is obtuse, find the value of cos theta and tan theta. We have some information. We are given that this angle theta is obtuse. So what are obtuse angles? It's always good to try and see where is theta. We said that obtuse angles, they are between 90 and 180. So where is our angle? Our angle is in this quadrant. And there we go. So we put and indicate our angle. This is our angle theta. And we are told sine theta equals 3 out of 5. Sine is opposite of hypotenuse. Sine theta equals 3 out of 5. But you know that sine theta is opposite over hypotenuse. That one gives us, meaning this 3 is the opposite sine theta. So the opposite is here. So this is 3. Then the hypotenuse is this. So that is the hypotenuse. Okay? And then we have to find now the magnitude of here. In O level and even in primary we studied about Pythagoras theorem. That if this is x, then x squared plus 3 squared equals 5 squared. So x squared equals, if I take this one the other side, this one is 25, then this one becomes a negative, 3 squared is 9. So x squared equals, this is 16. So what is x? You take the square root of 16. And x equals, not 4, but plus or minus 4. So x equals a plus or a minus of 4. Now, which of the two do we choose? You have to be careful there. Because the position of x would be different if it was this side. So we see that this is the zero part, the zero where it's supposed to be. So this side where x is, it is in the negative of the horizontal axis. Meaning for this case, we shall take x as negative of 4. So therefore, we shall have our x as negative of 4. That's what we are going to consider for this. So, what are we required of? Cos theta and tan theta. I can simply say we have this. This is our theta. This is negative 4. This is 3. And this is 5. So what is cos theta? Cos theta equals cos adjacent of hypotenuse. Adjacent is here. Minus 4 out of 5. Then tan theta, opposite over adjacent. 3 out of negative 4, which we normally write as negative 3 out of 4. Those are the values of cos theta and tan theta. See, if we had used x as positive 4, what would have happened? If this was positive 4, meaning this was going to be positive and the cos was going to be positive. But this is the second quadrant where only sign is positive. The cos is never positive there. You have to just know that. Therefore, this is the right way to do, and we can move on. We can have a second example. Given that cos theta is negative 6 out of 10 and theta is reflex, find the value of sec squared theta plus tan squared theta. We got our theta is reflex. What does it mean? It is in the third or the fourth quadrant. So it is either here or there. But then they are telling us this is the cos of the theta. And it is giving us a negative. What does it tell us also? We know that all scientists take chemistry. So cos is positive here. Much as theta can be here or here. But here we see that cos is positive. And this is negative. Therefore, this angle is only in this quadrant. It would have been in both, but the cos negative has knocked it out of the fourth quadrant. Therefore, our angle theta is in the third quadrant. Let's go. This is our theta. We go. Cos, adjacent of hypotenuse. So meaning adjacent is here, hypotenuse is here. And you can very well see that this 6 is negative because it is actually along that. Can we get the value of here? I can call it y. Use the same Pythagoras theorem. Y squared plus negative 6 squared equals 10 squared. Y squared equals, this is 36, when I take the other side, this is 100 minus 36. And y squared is 84, is 64. So what is y? Y is the square root of 64. And y equals plus or minus 8. So what is the right value of y? What is the right value of y from the positive or the negative? We can see the y is below this positive axis. It is below. So y will take up also a negative. So therefore, our y will be negative 8 in this case. So we go. This is our theta, negative 6, negative 8, and this is 10. What are we required of? Sec squared theta plus tan theta. I think we can first get tan theta, then we move on. So what is tan theta? Is opposite of adjacent. Minus 8 minus 6. And this gives us 8 out of 6. You can reduce it. You can reduce it and it becomes 4 out of 3. We need sec. From the beginning, we said a sec of a theta is 1 out of a cos of theta. Therefore, this sec squared theta plus tan theta is equivalent to 1 over cos squared theta plus tan theta. And this is equaling to cos theta. We have it there, which you can also reduce and becomes by 2 by 2, becomes minus 3 out of 5. 1. This becomes 1 out of minus 3 out of 5. Then squared. Then plus tan theta, which you have got as 4 out of 3. Squared is equal to, this can be 25 out of 9. Then plus 4 out of 3. We can go on and choose to follow the LCM. The LCM of 9 and 3 is 9. 9 divided by 9, it is that. So times that is 25. plus 9 divided by 3 is 3. 3 times 4 is 12. And this gives us 25 plus 4, which is 37 out of 9. That is our value. Did we use a calculator anywhere? No. Why? We are using the knowledge that we have already acquired. So some of these things we shall be doing them without following the calculator. However, it's good that you always have your calculator with you so that you can confirm to see that what you are doing is actually right. Can you do this? Do this. Please write. Given that tan theta, given that, let me write for you. This is our activity, that given that tan theta is -1 out of root 3 and that theta is obtuse, find the value of sin theta plus 2 cos theta. My friend, don't use a calculator. Follow the steps you have been following. Number 2, given that sin theta is -3 out of 5 and that now we are giving you theta in a different form, the range, and that theta is between 180 degrees and 360 degrees. Find the possible values. Possible values, I want you to mark that S. Possible values of tan theta minus 2 cos theta. When you get the answer, or even when you fail to get something, you can get us. We are back science education consultants. Get us on any of our contacts there, and then we shall come to your help. Let's move on. That one you can keep it for now. We still have one more thing to do. Moving to some special angles, and we call them set square angles. And these are the angles of 30 degrees, 45 degrees, and 60 degrees. What do you need to know about these angles? Just know their sine, their cosine, and their tangent. Okay? Just to know those ratios, then we shall move on. Consider a right-angled triangle. Consider a right-angled isosceles triangle ABC. This is our triangle. Isosceles, meaning this side is equal to that. And if this is 90 and this side is equal to that, therefore this is 45 degrees and this is 45 degrees. I'm just going to choose. Let me choose that here is a unit length. Let's say 1, meaning this one will also be 1. What's the value of here? If I can call it a C. The value of C squared is 1 squared plus 1 squared. Remember Pythagoras theorem. So C squared equals, this is 2. So C is the square root of 2. C is the square root of 2. And we are going to take the positive square root. So therefore, this is the square root of 2. Now, can we get the value of sin 45, cos 45, and tan 45? Yes. Sin 45 equals sin opposite over hypotenuse. 1 out of root 2. What is cos 45? Cos adjacent over hypotenuse. 1 out of root 2. What is tan 45? What's tan 45? Opposite over adjacent. 1 out of 1, which is 1. How I wish you can have these ones in your head. That sin 45 equals cos 45 equals 1 over root 2, whereas tan of 45 is 1. You can have that one. Let's consider another. This was ABC. Let's consider an equilateral triangle. Maybe PQR. This is our triangle. Equilateral from the word equal, meaning this side is equal to that, is equal to that, and this angle is equal to this, is equal to that. Meaning this is 60 degrees. 60 degrees. I want to do something here. This length is 2. This one is also 2. I'm just choosing any length. You choose any. You can call it X, you can call it P. But finally we shall come out with the same answer. If I divide this angle from the middle, so that this one can make an angle of 90 here, meaning this angle will be 30 degrees, and this one will also be 30 degrees. Then what's here? This is 1, this is 1, because we have divided it by, from here to here, was 2. Can we get the value of this? Maybe I call it y. How do I do that? Maybe I choose, this was P, Q, R. I can call this one O. I consider P, O, R. So, y squared plus 1 squared equals 2 squared. And this is y squared equals, that is 4 minus 1. And y squared equals 3. So what's y? Y is the square root of 3. So this is root 3. So can we, this one has become root 3. Can we get all that we want? Let's go. We have a 30 and a 60. Let's begin with 60. So what is sine 60? Sine 60. Opposite over hypotenuse. That is root 3 out of 2. What is cos 60? Cos 60 adjacent over hypotenuse. Adjacent is 1, hypotenuse is 2. What is that? Tan 60. Opposite over adjacent. Equals opposite, which is root 3, adjacent, which is 1, which becomes root 3. Let's go 30. Sine 30. Sine 30. 30 is here, opposite is here, hypotenuse is there. So sine 30 is 1 over 2. Cos 30. Cos 30. Adjacent is here, hypotenuse is there. Adjacent is root 3. Hypotenuse is 2. And tan 30. Tan 30. Opposite over adjacent equals 1 after root 3. We can convince ourselves that we have it all. By the way, do you realize that the sine of 60 is the same as the cos of 30? Don't say yes, don't say no. I know you are realizing something. What about between cos 60 and sine 30? Any relationship there? Look at tan 60 and tan 30. How related are they? Anyway, how related is 60 and 30? Somebody will tell me they add up to 90 degrees. Don't miss to understand more of these things at Back Science Education Consultants. We are here for you to help you learn what you could have learned from school, to help you remember what you learned from school, and to help you even get that one that is far beyond what you may get from school. We are saying learning must continue taking place, no matter the challenges. learning must continue taking place, especially in sciences, because we have sort of problems. That is it for now. Don't forget to subscribe to our YouTube channel, Back Science Education Consultants, and also inform friends to tell others to subscribe to the channel so that you can always be notified of whatever we upload there for your own good, for the better of our world. Thank you very much. I wish you can always be on that channel for daily updates.